Okay, in Chapter 12, we're going to deal with what's referred to as matrices, which is just considered an array of numbers where you have rows and columns of numbers. Now, these matrices are used to represent other things. Basically, all you have to learn how to do in Algebra 2 with matrices is just some basic operations. And the first thing that we're going to look at is just simply adding and subtracting matrices. So as it states here, matrices must be the same size to add and subtract. So when I say the same size, like in this case, I've got two numbers going across. Here I have two numbers going across. There's two numbers going down. There's two numbers going down. And you can just simply look and tell just by looking if they're the same size or not. So all you have to do when it comes time to add is just simply add the numbers that are in the same position. So like the first number we have here, first number we have here, you're going to add those. So if you do a -3 plus a -9, then you'll have a -12, okay? Then just go, I'm just going to go across. So this number and this number, those two numbers are in the same position. So you're going to add those, and that's going to give you 13. And then you just come down to your second row and just do the same thing. So the 9 and the 7, so that'll give us 16. And then 2 plus the -6 will give us -4. So this would be the answer to this addition problem. Now, subtraction works exactly the same way. So if you look at number 2 here, again, you can just tell by looking that they are the same size. Each one of them has 3 numbers across, and you have 2 numbers going down. So just simply subtract the numbers, again, that are in the same positions for each of those matrices. Now be careful and make sure you are picking up the subtraction sign each time. So if you were to do -8 minus -5, you get -3. Because remember, if you have minus a negative, that is the same thing as adding. So then you have 4 minus 2. And then 3 minus 6. 7 minus -1. 0 minus -5. And last, -2 minus 7 gives us -9. So you do your adding and your subtracting the same way. Again, they have to be the same size to be able to add and subtract. So with that in mind, if you look at this third example here, this would be an example of two matrices that are not the same size. So if you're asked to add or subtract matrices that are not the same size, you just simply can't do it, and you would just simply say that it's not possible. Okay, so that's your adding and your subtracting. Okay, so the next concept that we're going to look at in this section is what makes matrices equal. So matrices are equal only if they are the same size. So that's something that we've already talked about. And also, each of the corresponding elements has to be the same. Okay, so what that means by corresponding elements, that means the numbers that are in the same positions have to be exactly the same numbers. So in other words, the two matrices have to be identical. They have to be exactly the same thing in every way in order for them to be equal. Okay, so what you're asked to do here is to find the value of each variable. Of course, the variables that I have here are x and y. So here I have my x, here I have my y. But I'm told that these two matrices are equal to each other. Of course, you can tell by looking they are the same size. But those corresponding elements, the numbers that are in the same positions, have to be the same. So like if you'll notice already here, the first number that you have in each one of these are both 4s. And like down here, each of these numbers are both -1s. Now, what I have in the same position here as the x in this matrix is the -9. So that would tell me that x has to be equal to -9. Because again, you're told that the matrices are equal, those numbers have to be the same. Okay, so then if you look at your y, of course, here's your y. The 10 is the number that's in that position, so that would tell you then that y has to be equal to 10. Okay? All right, one more of those. Take just a little bit more work than this one. But again, you're told that these two matrices are equal to each other, okay? And again, we're trying to find x and we're trying to find y. Now, I have an x. Of course, what I have in the same position over here would be this 6, okay? Now, I also have an x here, and what I have in the same position there is the 9. So actually, in this case, I could use either one of those to help me out. I could say that, well, 3x has to be equal to 6, which would indicate that x has to be equal to 2. Or you could do the 4x plus 1. It would have to be equal to 9. Now, if you solve this one, of course, you'd start by subtracting the 1. So you'd have 4x is equal to 8. So x would be equal to 2. So, and I say or because you wouldn't have to do it both ways because it's going to have to produce exactly the same answer since you're looking for x each time. Now with y, this is the expression that contains my y. And what I have in that position in my other matrix is the 5. So you would say, well, 2y minus 15 is equal to 5. So to solve this, I would need to add the 15. So I'd have 2y is equal to 20. So y is equal to 10. So that's all in 12.1 that we're going to have to learn with this particular section.